Hello, it's LMTX. Today I will talk about the MQTT retained messages and how you can use them in practice. I will show you how can we use the MQTT retained messages to simplify both the edge and cloud logic of an IoT system. But what are the MQTT retained messages? The MQTT retained message is delivered to all active subscribers and also is delivered to any new device that subscribes to that MQTT topic in the future, which is a great feature. In this video, I will use an example that I described on my blog post. I will show you how you can simplify the smart home deployment using MQTT retained messages. Okay, so now let's use our MQTT knowledge to implement it in sample scenario, which is the scenario I used on my blog post. Let's emulate the smart home appliance, where we've got the MQTT broker, that is the Mosquito broker running on the top, and two smart bulbs. User can use application to change the color of light in rooms. First of all, let's connect to our MQTT broker. The client ID is going to be bulb 001. We want to connect to specific MQTT topic, and this is extremely important because you need to be very careful when you design your MQTT topic structure. So let's take a look at what I proposed in this blog post. For this specific scenario, I recommend that we are going to use the owner ID as a top level, house ID because the owner might have more than one house, room ID, and light. So, because we want to control light using this specific topic. So in this case, we will use the owner ABC, house 1, room A, and light. I will enable debug messages and verbose messages. As you can see, we connected to this MQTT broker. Now let's do it the same for the bulb 002. Client ID is bulb 002, the same topic. Room A, light. Let's enable debug messages and verbose messages. So this is the current setup, and now we want to enable our user to actually change color of light in the room. So let's connect as the application. We want to publish, and the client ID is going to be app 001. Of course, we want to publish to the same topic as those devices are listening on. So owner ABC, house 1, room A, light. And this is very important because we want to be sure that whatever configuration we will set for those devices will be also propagated to new devices. So we want to enable the retained messages flag, that is -R. Additionally, we want to enable debug messages and read our messages from the standard input. Let's say that our user would like to change the color of light in this room to green. So we're going to send the first message. And as you can see, both of our devices received this message and hopefully changed color of light to green. But what if something is going to happen in the future and one of those devices will break and we need to replace it? Let's say the smart bulb 002 got broken and user needs to replace it, let's say with smart bulb 3, for instance, right? And what's going to happen? We want to have the same color of all lights in our room, even if we connect brand new device to this room and subscribe to the specified topic. So let's see how that's going to work. As we can see, this brand new device received that retained message. This message was sent way before this device actually connected to MQTT topic, but because we used the retained flag, the MQTT broker stored that message and sent it to new devices that are subscribed to this specific topic. So this way, we can leverage the MQTT functionality. We do not have to implement any additional logic on the backend, because the MQTT broker is going to store this message and resend it to new devices, and we do not have to implement any logic on the device level to ask for the initial setup, right? Because once this device subscribes to this topic, MQTT broker will immediately send this message to new device. I hope that is interesting for you. I hope you learned something, and right now you understand how you can leverage the MQTT retained messages in your own IoT deployments. All the best, LMTX.